Today's lesson, it is an intro to exercise 21B. The name for it is called definite integrals. You've learnt indefinite integrals, and even in the indefinite integrals, you only learnt the reverse of power rule. So just to remind you, if you've forgotten, indefinite integrals, for example, this was the rule. Anti-diffing ax to the power of n, remember you need the dx. The rule says, instead of derivatives where you bring the n down and minus the n by 1, it's the opposite of that. So it'll be n plus 1. So instead of minusing 1, you're adding 1 because you're doing anti-diffs, you're doing reversive differentiation. Instead of timesing by n, you're dividing by whatever the power was. So hence it's divided by n plus 1. And that a value, whatever it was, y was there, it stays there as well. Okay, so the constant is always there. It's what you're reversing these steps here. Okay? And that's essentially what the power rule is. But remember, what are we also missing here? Plus C. Very good. Okay, so that's called indefinite because we don't know what C is. We don't know what that potential constant is. So there's an indefinite or so many possibilities. So the example I gave to you guys was if I asked you to find the derivative of x squared, you said it was 2x. I said, what if I gave you x squared plus 1 and find the derivative? You still said it was 2x. And then if I gave you x squared minus 99, it was still the same thing. The derivative of all these three functions still gives you 2x. So that means if you find the antiderivative of 2x, so if I asked you find the antiderivative of 2x dx, antiderive 2x dx, antiderive 2x dx, the problem is you don't know which one it is because that c value we never know. The antiderivative only tells you the function in reverse, but it doesn't tell you the constant. So we call that indefinite integral because we don't know what c is. Definite integral today, you're using a theorem called fundamental theorem of calculus. So for those who are really interested in learning it, there's a proof to it, and this is where it all began. You don't need to know, you just need to know how for the exam this year. Okay, so for the exam this year, this is all you need to know how to do. How do you find a definite integral? What does this symbol mean when you say 2, 3, x cubed dx? This essentially says antiderive x cubed between 2 and 3. In theory, that symbol actually means integration. And integration actually just means finding an area. So what that's actually saying is for the graph x cubed, which looks like this, for the graph x cubed between 2 and 3, so say 2 is here and 3 is here, find the area between 2 and 3. So the difference between indefinite and definite integral, one is going to give you an expression, a function. This one will actually give you a value because whatever the answer is, that's going to give you an area. Now, as a historical event, back then, in order to work out these areas, they don't know how to find areas under a curve. They can do it when it's nice rectangles. So they had a theory, it's called Raymond sums. They had to make infinitely small rectangles because the smaller the rectangles they make within the interval, they can work out the area. That's what the dx actually is. It's the change of the width of a rectangle. So that was what they used to do. And then two mathematicians around the same time came up with the idea that actually integration, which is the symbol, happens to actually be the same thing as the antidiff. That was a big breakthrough in mathematics. So that means that now, back then, instead of doing rectangles to find area under a curve, they realized actually if you know derivatives, you can just do antidiff and it will find the area under the curve. And that's where fundamental theory of calculus came about, right? So today, that was the background. what do you need to know? Just one skill. You're going to anti-diff this, so let's do it. We're going to anti-diff x cubed, so let's do what we've done in the past. Anti-diffing x cubed. What does this give me? Can I please have, let's go with Anthony. Do you remember how to anti-diff x cubed?
Plus 1 to the 3 and divide it by 4.
Beautiful. So is that rule? Remember the one I just wrote? Indefinite integrals, add the power by 1, so it's reverse the power rule, and then divide it because power rule you usually times, then now you divide. So you got x4 over 4. Now in definite integrals, you usually have to put a plus c. Isn't that right? In the fundamental theorem of calculus, that c actually ends up cancelling out, so we normally can't be bothered writing it, but you can if you want to. So if you put in the plus c for indefinite integral, now when we say 2 to 3, fundamental theorem of calculus says they figured out that if you found the area from 2 to 3, which simply just means subbing 2 and 3 in, they found out that if you found f of the top number, so subbing 3 in minus subbing 2 in, that will give you the area under the curve. And I usually prove this to you, but just for you to understand, this is what the fundamental theorem of calculus says. Copy this down. The rule will give you whatever the antidiff is, which they use the capital F, sub b in minus sub a in. That's the rule. Okay, so wherever the function is, if you antidiff it, becomes a capital F. So we've got the capital F. This is your capital F. You anti-diffed it. The rule says the upper interval, which is the larger value, if you subtract that from the smaller value by subbing it in, that's how you're going to find the area. So that's what I'm going to do. Now you'll see why the C's will cancel out here. See if I put in now the numbers, subbing in 3, so I got 3 to the power of 4 over 4 plus C. Take away, so that's my f of b. Take away, subbing in the smaller value, which is 2 to the power of 4 plus c. This is my f of b, so I subbed in b, minus f of a. Does that make sense so far? Okay, so I'm just following a rule. I'm not even telling you why this rule works. That's all you need to know. So this bit here was indefinite, which is what you learned to do by hand. Then the next step, to make it definite integral, they have to give you an interval. So they give you an interval, small number goes on the bottom, large number goes on the top, so it goes from left to right. And the rule says if you sub in the large number minus the smaller number, so top number minus bottom number, that will give you the area between those two intervals. You can do this by hand, but you can also do it on a CAS, which is what I'm teaching you today. And that's all you need to know for the exam. So for the exam, you just need to know how to plug that on a CAS, or if you were to do it by hand, how you would do it by hand. So here we go. You can see now, if I sub this in, do you see why the C's cancel out? So that's a positive C, but there's a negative outside the bracket. So when you expand the bracket, it becomes negative of this, but then also negative C. These two negatives will cancel out. So if you expanded that out, that would have gave you 3 to the power 4 over 4 plus C minus 2 to the power 4 over 4 minus C, and the C's cancel out. And because of that, normally we don't write the plus C. There's no point. Okay, so we're usually, when it comes to definite integrals, you don't have to put the plus C. When it's indefinite, you have to put the plus C. Okay? So that's always going to cancel out. And now we just need to figure out what 3 to the power 4 over 4 plus 2, minus 2 to the power 4 and 4 is. I don't know what 3 to the power 4 was. 3 to the power, oh, is that 81? Yes, 3 to the power 3 is 27. So 81 minus 16. 81 minus 16 on 4. I don't know this one. That's what? 11. Take away 5. So is that 65? Yes, 65 on 4. There you go. Do you need to know how to do this by hand? For next year, yes. For this year, not really. If you get what I was doing, fantastic. Then you can do it by hand as well. But all I really want you to do is how to do that on a CAS. So grab out your CAS. Here we go. Let's do definite integrals. Grab out your CAS. Go to the calculator page. It's pretty much a 2-button press. I mean, you can do it the long way, but we usually do the shortcut. So remember, once you're on this page, derivatives is shift minus, because the power rule, you minus, so that's the derivative template. So shift minus, but if you want anti-diff, it's the other way. It's shift plus. So if you press the shift button and you press the plus symbol, you should be able to get this template. What we're trying to do, 2 to 3, intervals from 2 to 3, function was x to the power of 3. Don't forget, you always have to have the dx. And hopefully we get the same answer, 6514. And yes, we do. That's all you need to know how to do. So in the exam, look for something like this. You see that, learn that. It was only two-button press. Shift, plus, type in an interval, type in the function, dx, because your exam, you're allowed to use a CAS. Unless the question says, show your working out or show your steps, then you do it by hand. But otherwise, if you see that kind of question, type on a CAS. Okay, so at this level, we're not expecting you to do applications with it. We do expect you to know how to punch in and know the difference between definite versus indefinite. Okay, for those who want to know how to do indefinite, so let's say, how did I get this? Or if you don't know how to anti-derive yet, and you want to get rid of that interval, all you have to do is just press delete. Press delete once you get the template, and that's your indefinite integral. So if I do x cubed now, whoops, that's what we got before. That's what Anthony said. X to the power of 4 over 4. What is it missing though? So when you do these on the calculator, you're missing. Don't forget a plus C. This is indefinite. This is definite. One's an expression and a function. One is a value. Does that make sense? Cool. That's all I wanted to show you today. So that's the skill. This is called definite integral. This is called indefinite. We'll do one more example so you can see how we're using fundamental theorem of calculus. But that's all you need to know. Okay, so as part of the exam. Next 2 sessions is discrete probability, and I'll guide you through that and what you need to know. Here we go. Let's flip back. Let's do another example. Let's try this one. I'm going to pause the video and give you a few seconds. I want you to find the indefinite integral of x plus 2x squared. Have a go with that first. Find the indefinite integral first. So find capital F of x. I'm going to pause the video.